Hi everyone, this is Mr. Murray. Tonight we're going to graph trig functions. And if you recall, the standard form of a trig function, right, is f of x equals a sine bx plus c plus d. But in the beginning, we're only going to worry about graphing with a's and b's. So as you can see up here in your notes, the graph of y equals 4 sine of 2 theta. So in this example, the a is 4 and the b is 2. Okay, so let's see how this graphs and what are some of the important parts of this before we can graph. So if you take a look at your notes, it says to determine the amplitude. Okay, well we have this acronym here that we'll call all cats play indoors. So the amplitude, which you remember from the last video, is 4. C, which stands for the letter B, it means how many cycles is going to occur within 2 pi. Well, you can see quite clearly that the answer is 2. Now, period can be found by 2 pi over b. So in this case, that would be 2 pi, and my b is 2. So the period of this particular graph is going to be pi, or 180 degrees. Now I stands for interval, so this is what's going on with this. We want to know, when we graph, what should we call these tick marks? Should it be 90 degrees, 180 degrees? You know, some of these graphs are going to get quite crazy. They're going to be fast or slow. So how do you know exactly what to put here for when you're crossing, right? How are you going to know? Well, that's the I part of this all cats play indoors. We're going to determine what should our interval be, and this is quite simply how you do it. You take your period and you divide it by 4. So for your notes, you just have to write this down once. It's period divided by 4. Or you could always do it this way as well. Period times 1/4. Okay, let me clear this out and let's graph. So let's finish this interval. What would an interval be if I was pi divided by 4? Well, that's exactly what it is. It's 1 pi over 4, or that's the same as 45 degrees. Okay, so now let's graph. We'll draw a y-axis here and an x-axis. Maybe I'll make this full screen now. So this is the sine graph, right? So sine, if it's positive, starts at the origin, and we're going to identify 4 points in our graph using these intervals. And the 4 points will be high, zero, low, 0. Let me show you what I'm saying. I'm going to plot 4 intervals here, and I'm just spacing them out very nicely. Every 4 lines, I'm just putting a dash. Cool. Now I know my interval is going to be 45 degrees, so this will be 45, 90, 135, and 180. Now you're familiar with what a sine graph looks like, right? It starts at the origin, it goes up, down, and back. This is considered one cycle, and the length of it is called a period. So what I wanted to show you was that the sine graph starts at the origin, okay? Our amplitude is 4. So let me mark this on my y-axis as such. We're going to start here, and our points will be high, 0, low, 0. In other words, at the first interval, we'll be all the way at our high point, which will be right here. At the second interval, we'll be back down at our 0. At the third interval, we'll be at our low point. And at the fourth interval, we will be back at the 0. High, 0, low, 0. So let's graph these. And there you go. That's the sine graph as given y equals 4 sine 2 theta. Perfect. Let's do another one. Okay, our next graph is cosine. And again, we want to know all cats play indoors. This is the information we need to make a graph. The amplitude is 3. The number of cycles, otherwise known as b, is 3. What's our period? The period is going to be 2 pi over b. Or, since we know what b is, 2 pi over 3. Now how much is that? Just so you know, it's 120 degrees. 2 pi is 360, divided by 3 is 120. Now how should we mark up our graph? What's the interval? So it's a little hard to divide 2 pi over 3 by 4. So remember what I said. To divide by 4, you could always just multiply by 1/4. So my interval will be 2 pi over 12, otherwise known as pi over 6, which happens to be 30 degrees. Okay, so let's put these in pi's this time. I'd like to set up my graph using pi intervals. Last time we did degrees, let's do pi this time. So I'm going to go to full screen again so that you can see a little better. Okay, so let's draw an x and y axis. There's my y-axis. Here comes my x-axis. We have an amplitude of 3. So let's put a nice 3 up here. Let's put a negative 3 down here. 1, 2, 3. Nice. This is cosine. So what you have to know about cosine is on the y-axis at the max. That's where it starts, if it's a positive cosine. If it's negative, you'll recall that it reflects over the x-axis, and it would actually be upside down, starting at the minimum. Okay, so in this case, it is cos. The maximum is 3, so the graph is going to start right here. Now let's set up our intervals. I usually go every 4 boxes just to keep it nice looking, like this. Beautiful. Okay. My interval will be pi over 6. So, right here, pi over 6. The next one's going to be 2 pi over 6. Or in other words, pi over 3. The next one will be 3 pi over 6's. Or in other words, pi over 2. Just simplifying the fraction. And the next interval would be my fourth one, my fourth pi over 6, which can be reduced to 2 pi over 3. Notice where the graph is ending at 2 pi over 3, which is the period length. So I'm just graphing one cycle of the cosine graph within the period. So it makes sense that my last interval should line up to the size of my period. Okay, so we know what cosine looks like. Starts up high, The first interval will be at its 0. The second interval will be at its minimum. Back up to 0 at the next interval, and up to the maximum at the final interval. Let's connect this graph nice and pretty. Do a little bit of a curve outward. Oops. Come down, curving through the bottom point, curving through the top. Look at that. That's the cosine graph. It looks beautiful. Here are our intervals: pi over 6, pi over 3, pi over 2, 2 pi over 3. I wanted you to get used to seeing those because they tend to use those quite often. But you know, of course, that this is the same as 30 degrees. This would be 60. This would be 90. And this would be 120. But very often when we're graphing, we like to see them in pi format or radians. Okay, let's do another graph. We could speed these up now. I'm going to draw a y-axis and an x-axis. This is a cosine graph, so I know I'm starting at the top. Where is the top? Well, that's quite simple. The amplitude is 4. So I'll go up here, make that 4. Down here is -4. Okay, I need 4 intervals now. 1, 2, 3, 4. What will those be? Well, let's work it out. In terms of cycles, how many cycles will this graph have according to the equation? It's theta over 4, so it's 1/4. So in 360 degrees, this graph will only expose 1/4 of it. So this is a very, very slow-moving graph. Okay, all cats play. What is the period? Well, if we're going super slow, the period's going to be gigantic. Let's just verify that. So period is 2 pi over b, which is 1/4. So holy cow, the period is actually 8 pi, which is 8 times 180 degrees. So this is a very slow graph. It's just very, very slow moving, and it won't even finish one cycle until 8 pi's, which is very slow. So then, therefore, what should our interval be? Well, we're going to take that and divide it by 4, right? So the interval is your period divided by 4. In this case, it's an entire circle. It's 2 pi. So let's label. First interval, 2 pi. Second interval, 4 pi. 6 pi. 8 pi. Notice again, the last interval is the period. Okay, we're a positive cosine graph, so we're starting at the top. The first interval will be our 0. The second interval will be our low. Third interval is back up at 0. Last interval, we're at the top again. Let's connect these in a nice smooth fashion, like you're diving off a diving board. Now you're swimming in the bottom of the pool, coming back up. And beautiful. Look at that. Very nice. That's the cosine graph right there. Perfect. I hope these are going very quickly for you now. Okay, so y equals a half cos of 3 theta. Amplitude, very, very small, 1/2. How many cycles is this thing doing within 2 pi? 3 of them. How long is a cycle? 2 pi over 3. And for those of you who don't live in West Virginia, you will recognize that as being 120 degrees. How many degrees or radians should each of my interval be? That would be my period divided by 4. So I have 2 pi over 12, or just pi over 6. By the way, that's 30 degrees. Let's graph. Y-axis, x-axis. Okay, a half. Wow, very, very tiny graph. It's a cos, so we start at the top. On the y-axis, we have 4 intervals, which we know to be each pi over 6. So the first interval pi over 6. The next interval, 2 pi's over 6, or just pi over 3. The next interval would be 3 pi's over 6, which can be reduced to pi over 2. And the last one, 4 pi's over 6, or reduce that to 2 pi over 3, noticing that it is, of course, equal to our period. Let's do the dots. So high, 0, low, 0, high. Okay, this is a very flat graph because after all, the amplitude is only a half. So what would you expect? It's sort of squishy, okay? But nonetheless, there it is. That's our cosine graph. Okay, so I would leave the last two for you to try on your own. To keep this video nice and reasonable, try these guys. Just remember, all cats play indoors. That will be very useful. And the same thing for this guy. Okay, give that a shot and we will go over that tomorrow morning in class. Hope you have a great night. See you tomorrow.